So I've been on a journey for over 20 years. It's how long I've been doing this professionally. And I've been on this journey looking for what's the most productive way to produce high quality code. So first of all, it's not about tools. We tend to get obsessed with tools and finding the latest, greatest tool. And we think that somehow if we have the right tool, if we just find the right tool, the right combination of tools, then that will solve all of our problems. So tools are great and they can help. But the point of what I'm going to show you is not that. It's not the tooling. In fact, even the fact that I'm using JavaScript is just because I think it's a language that most people are familiar with. It's sort of the most common denominator amongst languages, so that everybody can follow along. But you can do this in almost any language, almost any IDE. So what defines a productive workflow, or what's the key to being productive? So if it's not tooling, sort of what is it? And the way to explain it is this. So whenever you're coding a new feature, there is always unforeseen complexity. So you tend to get to a point where you kind of hit a wall. So you understand basically what you're being asked to do. You understand the behavior that your application needs to exhibit. You understand what the client wants, more or less. There's going to be some conversations and it might evolve, but you generally get what that is. And then you have an idea or a sense of what it's going to take to do that. And inevitably, you sort of hit this wall, this unforeseen complexity or this unknown problem, and it sort of it takes your estimates, throws them out the window, and it really messes with your productivity. The goal, I think, of a productive workflow is to solve for that unforeseen complexity. And what I mean by that is you want to be able to get to that point where you discover this unforeseen complexity as soon as possible. And so you want to start your work in an area that's going to uncover that unforeseen complexity, and you want to work in a way that's going to get you to see that unforeseen complexity sooner rather than later. And so that's really the point of what I'm about to show you. There's some other things in here that might make you a little nervous or uncomfortable. You might have some assumptions about, but don't worry. I'll go through it and I'll explain. And I just ask for your patience. Hang with me, and you'll see this is I think it's gonna really help you, because it's really helped me. Listen, if you're new, if this is the first time that you're watching me or this channel, I invite you to subscribe to learn more about how to improve your code and advance your career. Subscribe, hit the notification bell so that you don't miss an episode. I'm pretty excited to jump in. So here we go. All right. So this is basically how I set up my monitor whenever I'm coding. So there are 3 distinct sections. So on the left-hand side, I have what's called a spec. So this is the specification for what I'm going to code. On the right-hand side, I have the code that is going to implement this specification. And on the bottom, I have a test runner that is watching for changes and giving me consistent feedback. And now I know you're looking at this and you're going, well, hold on a minute. You're talking about test-driven development now, and maybe you've tried test-driven development and you're like, oh man, I tried it. It doubled, tripled my workload. It was so slow. It didn't help me at all. It was confusing. I didn't know where to start. Look, bear with me. I will show you how to do what I consider to be test-driven development in a productive way. I'm hesitant to say the right way. I don't want to get into big arguments over what's right and what's wrong. I think we do that too much in this industry, but in a way that I have found, at least for myself, can make you very, very, very productive, and can avoid a lot of the common pitfalls and traps that I think a lot of people experience with test-driven development. I think there's a lot of TDD out there that is sort of setting you up for, if not failure, at least for a lot of pain. And I'm going to try and show you in this video how to avoid that. Okay, so notice a couple things. So one, I've written the spec in terms of to-dos, right? And so you may not be using a language or a testing framework that has this concept of a to-do, but that's okay. the point here is that you do not want these things to be failing tests. You want them to be tests that are not yet executing. And so whatever you have to do that, whether they're skip tests in the testing framework that you use or unimplemented tests, whatever it might be, you don't want to get a false signal that a test is failing when you've yet to implement it. The other thing is, so in this case, we're dealing with a feature, we want to build a shopping cart, right? And so this spec is going to describe our shopping cart. And it's going to describe it from the standpoint of the behavior of the shopping cart in a manner that might be familiar, at least at first, to our client. And it's not because we're going to share this with the client. In fact, that's a bad idea. It comes from there's a branch of behavior-driven development and a style of test-driven development where you actually you let your client look at the tests and you do tests together. I have not had good experiences with that. Maybe you have, maybe I missed something, but I don't recommend that. This is for you, but what you want to focus on is writing out the behavior that your code has to implement, not the implementation details of the code. So these descriptions here are not about, talking to a database. They're not about, any really detailed level or specifics about certain kind of branching logic or anything. It's really plain language, simple, it's a shopping cart. You need to be able to add an item, remove an item, update an item's quantity, list the items, and then calculate a subtotal price. So this is just the behavior that we would expect to see in a shopping cart. And you should know this going in. So you should have a sense of what it is that you're going to build. And you don't have to worry about knowing how you're going to build it. That comes later. So let's jump in and I will show you how I would approach these kind of tests. And there's going to be things in here that I think are going to surprise you in terms of what you may think test-driven development is and how I'm going to do things. So obviously, the first things we're going to need to do is we're going to need to import the system that we're testing. And so basically, I'm importing this make shopping cart, which is going to be the system that I'm testing. And that's, you can see it's on the right hand here, right? Make shopping carts. I haven't implemented anything yet. And my shopping cart, my make shopping cart here takes a database parameter. And the database parameter is just something that represents a data store where the shopping cart can store and retrieve items. So if I had a real database, I would actually use the real database in the test. When I say the real database, I mean a local copy of the database that I can sort of play with, a local instance. I would write my test so that behind the scenes it's talking to the database. That's okay. There is nothing wrong with that as long as you're not executing queries that are going to take forever. You will be productive and your test will actually be a lot more meaningful because they'll be talking to the real thing. In this case, I don't yet have a database, and that might be the situation for you as well. And so what I've done is I've created a fake database. I've stubbed it out. So I have this shopping cart DB, and all it's doing is behind the scenes, it's using a map object. Okay, and it's just it provides a few methods. So find by ID, insert, list, remove, update, and all of these methods just basically interact with an instance of the map. And so this will eventually be replaced by an adapter to a real database. But the point is the interface should be fairly stable. So I'm expecting that whatever data store I end up using in real life will expose the same interface. The other thing to note is that this shopping cart DB is not a mock. Okay, so this is not a mock. You might call it a stub, but it's not a mock. And the reason that I make that distinction is a mock is code that actually has embedded within it the ability to do assertions. Okay, and mocks can get you in a lot of trouble. So I try as hard as I can to avoid using any kind of actual mock in my code. And when I say actual mock, I mean an object that within it has some embedded assertions. So things like a spy, or, well, in this case, I'm using jest as my framework. So I could use jest.fn or jest.mock, and it would create a dummy object for me that I could actually run assertions against. And the trouble with doing that is then you end up really testing your mocks and not testing the real thing. So like I said, my first best bet is, if I have a real database, use the real database. My next best thing is to stub it out with an interface that is going to simulate the database. And so just to go quickly here, because we're going to be testing this shopping cart, I'm just going to grab a little bit of code here. Okay, and so boom. And so what we've done here is, so we've got this cart object that we're going to reuse. And before each of my tests, I'm going to go ahead and make a new dummy database object, and then assign the cart to a new instance passing in the dummy database. And so what this is going to do is it's going to ensure that the tests are independent of each other in terms of each time it's going to use a fresh database. And so we won't have the one test polluting another test. And that's really, really important, test independence. It's also something else that is a little bit misunderstood. And I'll show you in a second where there's some confusion comes in. So let's go ahead and let's implement this first task. So hold on, I'm going to save this first and make sure I didn't break anything. Okay. And so the first task that we need to implement is, it adds an item. So we're going to remove the to do from here and then pass in a callback. And because dealing with this kind of code is going to be usually asynchronous, so we're going to make this async. And don't get too hung up on the semantics or the syntax of the JavaScript here or of the Jest framework. If it's something that you use, great, you might learn something. But if you're using a different set of tooling, don't worry. This is not about the specifics of the language or the tooling. Okay, so how do we write a test for whether or not the shopping cart can add an item? And so first of all, where are we in the code base here? What are we interacting with? So there's no UI at this point. I mean, there might be a mock-up somewhere that someone made, but this is not the UI. This is not a web service or a RESTful endpoint. This is not some database adapter. So what is this exactly? So this is an object, a plain JavaScript object that is going to encapsulate all of the business logic of interacting with a shopping cart. So it represents, it's an object that represents the domain concept of a shopping cart within our application. And this is where I always start, and this is the place from which I like to test. And the reason is because this is where you're going to discover that unforeseen complexity. So remember, I said with things like if it's a problem because if you're using some UI framework that maybe you're not sure how to do something in, you can Google that. If you're using some database that you're not sure how to do something in, you can Google that. When you're trying to accurately represent the interactions required for your application based on the business and the logic and the particulars of your business, that's going to be impossible to Google because it's going to be specific to your particular circumstance and your particular application. So really important that that's where you start, because that's where you're going to uncover the hidden complexity. And what I'm trying to do with this workflow is I'm trying to take these tests and turn them green as quickly as possible. So now if I write my test here, it's going to look like this. We need an item of some kind that we're going to have to add to the database. So we're going to give our item an ID, just something random, and a name. We'll call it the Code Master 3000. Okay, and then maybe a price. And usually price is in like pennies, so maybe it's $39.99. This thing, I don't know what it is. I mean, I'm just making it up, right? So we have this item, right? And then what we're doing is we're going to pretend that the shopping cart module already exists. That this shopping cart object, this cart thing here, has already been coded. So what would it look like to add an item to this cart? So I'm going to say we're going to do something like cart dot add, and then we're going to pass in our item. So that seems like a sensible API to me. And now the question becomes, how do you test, what do you assert to make sure that the item has been added to the cart? And so the tendency with a lot of TDD that I see out there is, oh, I need to reach for a mock, or I need to interrogate the database directly, or something like that. I'm going to say no. What I'm going to say that you should do is, you notice here, there's later on, we're going to have a method that lists items. And so if you were running this code from the perspective of the consumer of the code, what would the consumer of the code expect to be true when an item is added? So I would argue that once you've added an item to the cart, the consumer of this code would expect that when you list the items, that the item you've added appears in that list. And so I'm going to suggest to you that the way to test this is to do exactly consume the code exactly as the user of the code will consume it. To make that sounds very complicated. To make it super simple, what I'm saying is we should just go ahead and assert that when we do cart dot list, maybe list items, that's going to return you a collection that contains the item that we're looking for. So again, because I think this code needs to be asynchronous, we're going to make this an await. And so we're going to say expect cart dot, maybe we'll say get items, cart dot get items, and we're going to have to await that as well. And we'll say to contain equal our item. And so again, don't get too hung up on the specifics of the Jest library unless you use Jest and you're interested in it. The point here that I'm making is it's perfectly acceptable to call two methods of your object in one test. So even though this test is about testing the add, I'm going to tell you that it's okay to call the get items in order to test the add. Okay? Because by virtue of this before each up here, creating a new cart each time, I know that our tests are going to be relatively independent. Yes, it's true. If get items or add breaks, then this test will break. But think about the real scenario. So in the real world of this code, if these things are linked, so if one of them is not working properly, your app is not working properly. So that's actually okay, and it's a benefit. It's a good thing that you're using these two. So now, if you see down here, we've got ourselves a failing test. So we've got to go ahead and implement it. So let's do that. And so this will have to expose an add method, and it's going to have to expose a get items method. And then we'll implement the add method function add item. And this is going to be asynchronous. And then we're just going to return db.insert item. And we're going to have to do an async function for get items. And that is going to have to, what's it going to do? Let's look at our thing. Okay, so that's just going to return our this list function. So we're just going to, here we'll return this, and we'll return db.list and save. Okay, and so now we have a passing test. And I'm just doing the absolute minimum that I need to do to get this test to pass. So this is probably not the final version of these functions. We're going to have to probably add more logic here, but I just want to get to green as quickly as possible. Hey, it's Bill Sarur here. So when I originally recorded this video, I coded for a lot longer, but I think you get the point of the workflow that I'm trying to recommend. If you want to see a more in-depth video specifically about my approach to test-driven development, please leave a comment below and I'll do my best to get that to you. Okay, well, this has been an episode of Mastery Monday. Thank you so much for watching. I hope you've gotten value out of this. Don't forget to subscribe and hit the notification bell so that you never miss a future episode. You can also get my newsletter at www.devmastery.com. I look forward to seeing you there. Have a great day.